Well, good morning, everyone. To put on my little prosthetic here to get to my presentation, which has gone to sleep, but we will get started shortly. And I have to say, it has been a real privilege to be here with all of you this last couple of days. I don't frequently get to participate in a learning activity where I feel like I'm going to leave here a better person than I came. And I don't mean you transform me overnight, but you've given me some new tools and you've challenged me to think about things differently, even though I think that's what I do every day. So it's been an amazing experience, and I want to thank the MLA. I want to thank the team that helped interview me and get me ready for this, and I want to thank all of you for your patience and your interest in what we're about to talk about. Now, what I'd like to do first is just set the stage. Because yesterday you heard from a company that's $100 billion. I can only dream of that. 3D Systems closed last year at about $650 million. In the time I've joined, we've gone from $100 million in top-line revenue to that 653. So it's been a rocket ship in 5 years. And it's kept me pretty busy. But there's a great story here about the technology and what it has done and what it will do. But I want you to know that what it will do is really up to you. So 3D printing has been around for a long time. Anybody here have really good knowledge, interaction with 3D printers? Some experience? I see a couple hands. That's great. Anybody want to wage a guess about how long it's been around? 5, 10? 25? Do I hear 25? Going once, going twice? I hear 30. Next year will be our 30th anniversary. So we've been at this for a very long time. And it's been a really interesting and rocky ride for us. Our founder, Chuck Hull, who just did a quick flyby, created 3D printing to allow people to rapidly prototype and get products into the market. We didn't have any other tools available at the time. 30 years ago, everything was handmade. It took months, if not years, to get a new product to market, and you spent millions and millions of dollars trying to get it done. With 3D printing, we were able to create prototypes in a matter of hours, worst case, a couple of days. That dramatically changed the industry and gave us new tools so that we could be more competitive, we could create more revenue and more opportunity. And the very largest companies embraced this technology and ran with it, from automotive to aerospace and defense, some healthcare, and certainly the larger universities that had design schools and engineering schools. Are you advancing my slides for me? It's magic. So here's where we are today. That's Chuck at about 47.
The fact that they really are the inventor and the establisher of this technology.
And the things that we do now, within a day, 2 days, would take months to build by hand.
That's probably my favorite line. We invented it, but now it's your turn. Because in the first 30 years that this technology was available, maybe 100 million people actually interacted with it, used it, made it change their businesses. In the next 10 years, as we've worked hard on democratization, bringing down the price points, touching new industries almost every day, we think it's the next generation that's going to change the use of 3D printing and make it the magical solution that it can be. So what I'd like to do is just share with you why that's so important. It's not about the technology. I don't want you to walk out of here thinking that I believe 3D printing is an industry. It's not. What it is a method to change the way we manufacture. Okay, it started as prototyping, concept modeling, testing, but today it can become a way we manufacture. We can literally adapt and change almost at a moment's notice. We can relocalize manufacturing. That's up to us. We can do more sustainable manufacturing. We can adapt and create better, faster, more complex products. I mean, if you think about it, our smartphones today carry around more computing power that this whole room used to take up, right? And those have to be prototyped and created and presented to the market. And those turn around about every 6 to 12 months in terms of our desire and demands. Those couldn't get to you without this technology. So think of this as a way to change your supply chain, change the way you think of providing products, and really use today's discussion, if you will, humor me for a little bit, to think about how you might change your market and your customers. So in 30 years, we have developed lots of products. We have them starting at under $1,000 for the desktop, all the way up to over $1 million if you're looking at full-fledged manufacturing and now direct metal in particular. So anything you need is there between us and a couple of other suppliers in the market. It's not about a lack of printing technology. What it's about, though, is a little bit of what Justin was talking about. It was thinking differently. Today, when designers and engineers are thinking about new products, they're worrying about how easy it will be to manufacture. How can they create the tooling? How can they get the molding in time? 3D printing prints whatever you send to it. It prints it layer by layer by layer. So complexity is absolutely free. You can send 30 different objects to it in the same build envelope, and it will print all 30 at the same time, and they'll be completely different and unique. You can also take a highly complex item that couldn't be manufactured any other way, and you can now manufacture it with 3D printing. And that's why you're going to see some of the amazing applications I want to share with you as we go through today. And I'm going to do this with a lot of video because sometimes it's hard to believe what can happen if you don't see it. I can describe a lot, but the videos will tell you some great stories. Now, 7, 8, 9 years ago, we participated in a couple of industries that had some challenges in terms of how they addressed their customers. In-ear hearing aids were uncomfortable. They had a very low compliance rate. They were also returned very frequently, making them very expensive. We took that opportunity to work with suppliers using in-ear scanning, and each side is different. We created custom in-ear hearing shells. Those are stuffed with the electronics, and voila, today, 99.5% of all in-ear hearing aids are 3D printed. There's no reason to do it any other way. On the opposite side, many of us have had to have our teeth straightened, and I have a warning for you. As we age, they move again. So, buckle up. But 2 Stanford grad students came to us about 12 years ago, and they had this idea that why couldn't you straighten teeth without metal? So it was their idea. We simply helped them develop their process using our technology. And the cool thing about this is it is scalable. 20 million individual unique aligners were printed just last year. And they're printed in this fabulous lights-out factory. And the growth continues. And this proves that 3D printing not only can do unique and complex items, but it can mass produce based on the application. So this gave us a lot of opportunity to really think differently about lots of other applications. But staying along lines with the healthcare, I think it's also important to see that we have lots of opportunities. So I said complexity is free. I talked about unique and complex shapes. The body, the human body, is the most complex organism in the world. We are. So thinking about how we can use 3D printing to enhance patient outcomes in a surgical process, to improve the quality of life, to give you a custom knee implant versus an off-the-shelf. And oh, by the way, give you simulation in terms of training your physicians so they can practice using 3D technologies before you ever get close to that knife, because the statistics show that a physician has to do about 500 surgical procedures before they become proficient. I don't know about you, but I don't want to be patient number 300. So think of 3D technologies as beyond the printing. There's visualization, there's scanning, there's all kinds of ways we can improve life.
I came across Derby a little bit 3 months ago now, I think. I had adopted a dog who was a rescue group called Peace and Cause. He was born with deformed front legs. And I kept looking at his photo, hearing his story, and I tried literally every time. Finally, I messaged her and I said, okay, I'll do it, foster, I'll take care of him. I had to try and help this dog. We decided to get him a cart, which worked quite well, but they limited his mobility in terms of being able to play with other dogs, and it's not really the full motion of running.
Throughout this project, we're using a variety of 3D technology, and that allows us to get in there and really modify the organic digital models quickly and easily, and start to do the sort of design that Derek wants us to do.
So notice how the gentleman had a visualization, and he was working with that design organically. He could make changes, and they came up with this amazing wheel-like apparatus for this dog because the cart didn't quite work. It didn't let the dog interact. It didn't let the dog really have the full motion of running. So by working hard and looking at the different potential, we came up with this concept of printing these specific prosthetics using this multi-material machine. So you can see it's printing by the layers. And here's the new owners of the dog who have made the final adoption, and they're introducing Derby to these prosthetics. And we really didn't know what the outcome would be, quite honestly, because this dog had never really walked in its life on all 4 legs. So here we go. You're going to see the family introduce the prosthetic, and there goes Derby, just takes off running. So we learned from this that you can do a couple things. You can engage your own employees to think about how you might use your technology, and you can do customized prosthetics for people or animals, your best friends, and get them back to running, which is an amazing use of the technology. So I just wanted to share that with you because it's a great, great story.
This is what treatment is all about. To be able to help anybody, dog, person, whoever, to have a better life is just, there's no better thing to be involved in.
And I would agree with that. Now, this affects lots of other people in lots of different areas. Young girls growing up with scoliosis, it's a very painful, very difficult time for them. And any way of fixing the issue is problematic. It's heavy-duty bracing, it's hard to wear, it's uncomfortable, and the young girl is embarrassed. It's a very difficult time in her life. We can customize that brace, make it form-fitting, make it breathable, make it comfortable, and she can literally put it on and put her t-shirt over it. We're finding that young girls are thinking of this as a fashion statement. And if they wear the brace, it's going to prevent downstream surgical processes that nobody wants to go through. So again, another use of the technology that's quite impressive and important.
I've been paralyzed for 22 years with no sensation or movement below my pelvis. What defines a person? What if technology could improve your quality of life, give you freedom of mobility, but also become an extension of your senses? The bionic exoskeleton or wearable robot has come to represent a true technological biological fusion as the most complicated neuroprosthetic ever imagined. Design engineers from 3D Systems teamed up with Exobionics to create the first hybrid 3D printed exoskeleton. I became an integral part of the design process. I was dressed in a skin-colored unitard as the team scanned my body while I was sitting and standing in a robot. These images were then passed onto a computer screen. The goal was to create custom 3D printed parts that connected my body accurately and symbiotically to the robot. These fixed interstitial parts
So Amanda is a very articulate, attractive woman that was in a ski accident over 20 years ago and has been paralyzed from the waist down ever since. When you think about technologies, think about them in terms of multiples. 3D printing is one of what we call exponential technologies, but so is robotics, so is artificial intelligence, so is big data. And a lot of these technologies, including sensing, are coming together right now to give us opportunities to create new products that we've never had before. So the exoskeleton, of course, is robotics. The problem is they're not custom made. And it put pressure on parts of Amanda's body and abraded her skin, creating huge issues that she couldn't even feel until after she took the suit off. By custom designing these inserts using 3D printing, they're breathable, they're lightweight, and now they provide the full range of motion for Amanda, but they don't injure her body. So think about, again, how these technologies coming together might change and improve someone's life in the future, because she's just the tip of the iceberg when it comes to these types of opportunities. But she's an amazing story. Now I want to segue into how others are using the technology.
That might be the difference in 1 or 2 points of fuel burn in the way jet engine works, and that's billions of dollars for our customers in terms of performance. Now, the way that's made today is kind of subtractive, right? You can get a block of something, and you weld it, and you arc it, and you take the strap, and it goes someplace, and that's how you make those parts today. And 3D printing allows you to make that product right the first time. It allows you to make it from the core up. So you basically don't have as much waste. The tool is cheaper, the cycle time is faster, and that is the holy grail.
Now, you couldn't pay someone like Jeffrey Immel to say your technology is the holy grail. That's a gift. But the message is his company now has positioned 3D printing as the way they're going to create their next jet engine. So the LEAP engine is all about 3D printing, and Samantha mentioned that yesterday, and they're using it for the turbine blades, they're using it for the little jetters that feed the fuel into the system, and they are completely bought into the power of 3D printing. And we think that they're going to really convince others to leverage this technology because of what it can do for very complex parts, like a jet engine, like aerospace and defense. So a very important user. But I want you also to understand that the technology has such limits in terms of the barriers to entry now because of the fact that you can get it online, you can get it through cloud printing services, you do not have to own the technology. So companies like Planetary Resources, which was formed by a bunch of prior rocket scientists, are creating space vehicles to go up into outer space. They just launched one about a week ago off of the Cape, and they're running their tests right now, but it will be going to the ISS in the next generation, which is about 60 days from now. The idea here is they turned out a space vehicle in under 2 years, in under $2 million, easy for me to say, and it has fewer than 100 moving parts. So using 3D printing, they were able to iterate very, very quickly and take advantage of the technology to get into the market sooner. They're going to be capturing asteroids and bringing them back to Earth, and we're going to harvest those for precious metals. And we're already doing some of that and using it in our direct metal printing. So an amazing use of the technology, a little startup in Washington State, and they're already going to space in the next couple of weeks. So pretty good use of the technology. Automotive is where it started, but think of it as transportation, anything that moves, including boats, okay? So we started with the ability to change the way they rapid prototyped so that they could get concepts and models to the market sooner. Now they use it exclusively for that plus aerodynamics testing in wind tunnels, critically important to anything that moves, for fuel economy, as well as are you getting the best airflow, are you getting the best speed, et cetera. And today they're also using it for bridge manufacturing. So if they have an issue getting a model to market, and this happened with the Volt, you have to create test vehicles to get out on the road. You won't have time to get your manufacturing line up. So they actually printed significant parts of those models, and they also used it for bridge manufacturing. Someday, more and more of these companies are going to be using it for on-car parts, for personalization and customization. And we see that right now with Formula One, because they have to make constant changes while they're out on the road. So they now do not only the wind tunnel testing and the prototypes, but they actually print lots of on-car parts during the course of a season. And those companies have about a $500 million budget during the course of a race season, which is amazing. I'd love to have that for about 5 minutes. So automotive has been really, really important. Transportation, think of it as all things that move can benefit from the value of 3D printing. And in fact, that one of the motorbikes up there, we printed the fairings for all of the test runs. It went out and ran thousands of miles, and one day I get the call, we're sorry to report we had an accident. Was it my fairings? No, the engine burnt out. So the 3D printing kept up with all the testing, and that product is now in the market. So really good way to challenge the way you go to market today and the way you create your products. Now, fast forward 28 years into it, and we have now direct metal. And direct metal is sort of the next generation of how we might produce. And in fact, I have a little 3D printed bracelet that I like to carry with me that was printed with all of the links intact, workable, comes out of the printer, and then I can wear it. It's a little large, but I still like it. I'm going to pass it off here to Terrence. Good catch. And take a look at it as it goes around the room, because I don't think we have any metal next door. This is an amazing use of the technology. It still prints layer by layer. It has to use higher wattage lasers to get it done. But this is your next generation of how you might produce end-use parts and end-use products, similar to the way GE is doing the jet engines for the future. So really, really exciting time for the industry. Now, I've talked a lot about technology, hardware, printers. That's a key part of it. But materials are also essential. As we look over the next 10 years, we're going to need to go from the 100+ materials that we have as a company today, and maybe another 20 or 30 that our competitors might offer, and really change material science and get to the next generation materials. Materials that will be lighter in weight, more flexible, different kinds of metals. Everything needs to be considered, because today we have a great variety. They're serving the market well, but I think the next generation will be even better. So material science is just as important, and in fact, in some cases, it might become more important in the future. I mentioned that you don't have to own the equipment. I want to reinforce this message today, because if you haven't started in 3D printing, the best way to do it is to create your model, upload it to anybody's cloud printing services. Ours is 3D Systems Quick Parts. These systems will give you a quote. They will recommend materials. If it's not clear to them what you're trying to accomplish, they will have a project manager call you, walk you through the material selection, and then we will print that part, that product, and ship it to your residence, your business, wherever. And because we have this infrastructure now, it's starting to inform how we deal with consumers. So we'll talk about that a little bit later, but this is now a global footprint. Anywhere in the world, you can upload a part, print it, and have it shipped directly to you. Really important for someone who wants to look at the space. This is a quick snapshot of some of the companies that we've worked with over the years. And these are the companies that will give us permission. I don't know whether you noticed, but back in the first video, there was a little snippet of Apple using the technology back in 1989. So they've been a customer from the very, very beginning. But not everybody will let you use their logo. But it's a good start, and these companies are moving now deeper into the value chain of 3D technology with scanning and with manufacturing as end-use parts. So that's a little bit of the historical part. Now what I'd like to do is share a little bit of where this is going and how it's going to impact new applications and change the way we might look at products that we get today. In fact, I want to share with you that everything you own, from your shoes to your eyeglasses to your personal PDA, smartphone, whatever you call it, to the car you drive, the airplane you flew in, all those products get to you through 3D printing. Whether it's ours or someone else's, you can't get a new product today without using this technology. So what can we look forward to in the future? I've turned off Jeff on purpose. I don't want him to distract, because he's very proud of this engine that we're running here. We think that the next generation of 3D printing has to embrace traditional and additive manufacturing. because we're not going to blow away the manufacturing sector. We want to be part of that $35 billion opportunity, right? So we have to find ways to integrate into some of those needs. By approaching this concept of a racetrack, we're able to look at printing 4 billion drops of material every minute. Now that's a lot to think about, but that gives you amazing printing power and speed. So this will be about 50 times faster than any solution in the market today. The racetrack is interesting because it allows you to take something off track for a pre or post-processing step. Think about taking it off track, throwing on an antenna, getting it back on track, and printing the next several layers. So you could have almost a cell phone printed in that type of a process. This allows us to think about additive and traditional manufacturing as a powerful solution in the future and really move it into a digital fabrication. It allows companies to think more carefully about relocalizing manufacturing and taking advantage of the technology. So this has just been set up in our Oregon site, and we're going to be inviting customers and prospects in to see it over the next 6 months. Really interesting new use of the technology. This is one of our favorite customers that started using color 3D printing so that they could lay out a full line of new running shoes or other athletic shoes so the buyers could stare at it at the beginning of any season. They didn't have to spend 3 months building it. They could literally roll it out, and you could look at the colors, and you could make your choices. Now they've taken it to the next level. They're making custom cleats designed for a runner's step to make them faster, to actually conform to their performance levels. And again, this is just the beginning, and Nike's just the first out of the box, but you're going to see more customization to think about things like performance and using sports equipment better. Now, this is one of my favorites. This is a long-standing customer, and they don't make 3D printers. They use them across their various applications. But what they've done here is they've created a very interesting video to inspire their company and some of their prospects about using 3D printing to actually build a plane from the ground up. Now, I would tell you that in my opinion, it's probably not doable in the next 5 to 10 years, but I love the creativity, and of course, we love the fact that they're using 3D printing in this metaphor to educate and inform and probably spark creativity on the side of their employees. But this one, probably a little farther out. One of the things we have to consider is the people that design for us. Most of us in this room can't create a 3D printable file today because it's done in CAD, and it's very complex, and it takes a bit of skill. So we've also been working, and other companies have been working on creating tools at the desktop to make it easier to design, to make it easier to capture content with scanners. And there's a couple of scanners that you see on one side of the screen. Why would you spend 10 man-hours or 100 man-hours creating an object if you can scan something that's a reasonable facsimile and then take it to the next level with your design prowess? That's an accelerated way of doing design. You can also use scanning to actually inspect the product that you've designed after it's been printed to make sure that it conforms to your design intent. So scanning and these tools are extremely powerful. The device closest to me, the little black item, is a haptic tool. And it allows the designer to go in and interact with the design, change it like they're working in clay. It gives you tactile feedback and allows you to sort of drive the bus and create anything you want. We think this is going to be increasingly important as more and more of us would like to interact with 3D printing technology. So keep looking for those changes in design. Now I'm going to share one of the reasons why that's so important. At the top of the screen, you see something that I'm sure you're wondering, what is that? That's the cross-section of a bird wing. Somebody mentioned biomimicry yesterday. Well, biomimicry suggests that the best things that have ever been designed were designed by nature, and they've evolved, and they have continued to improve their performance through the evolutionary process. Well, a bird wing is one of those amazing creations. Could we use that to change the way we design? So this is a metal bracket that's widely used in strapping engines to wings. very heavy, puts drag on that wing. Can we change the way we think about it, open it up a little bit, like a bird wing, and then end up with a product that's really designed for optimum performance? Because now I can manufacture it because I have 3D printing technology. That's the end bracket design that came out of that thinking, that came out of copying the way the bird wing is structured to give it the best possible performance with the lightest possible weight. So that's why changing our design thinking is so important. And that's why sitting in Justin's his workshop yesterday was so fun for me, because we do have to keep thinking differently about the way we design. Now here's a simple object, our eyeglasses, sunglasses. And we always lose those little screws. And then we have to go buy a new pair or find those little tiny screwdrivers to get them back in. These are designed with 3D printing in mind. It's a living hinge. There's no screw. It's one piece. And while we don't produce the lenses today, that's next. That too will come. And these, in the future, you'll literally go up to a scanning device. It'll scan your face. It'll look at the bridge of your nose, where your cheeks fall, or don't fall, hopefully. But it will actually create a file that will print custom glasses that will fit to your face perfectly. And that, again, is the power of combining the technologies, not just the printing, but the scanning and the design thinking. Fashion. A lot of people have grabbed onto this recently, including our Chief Creative Officer, Will.i.am. He's been fun to work with, teaching us lots of new ways of thinking. And anything you can imagine that you need to wear can be 3D printed, and you're going to see more and more of 3D printables. In the top corner, this young lady is working with a sub-$5,000 printer to create custom jewelry. And she's able to create the castable model in a matter of about an hour and a half, and now she's got a beautiful piece of jewelry that's available in the market. And that's changing her paradigm pretty dramatically. If I go to the next slide, you can see some lovely dresses and more fabric-like solutions that we are 3D printing. And these do have flow, and they do feel comfortable enough to wear. But again, as we look out over the next 5 years and see what happens with material science, we'll have even better, more exciting materials to work with. And that's an Iris von Herpen dress that I wouldn't be comfortable in no matter what. But it's beautiful, and they call it icicle for a reason. Ceramics. What if you could take an industry that's thousands of years old, and people love ceramics, they love pottery, but it's very time-consuming. And if you make a beautiful piece, guess what? You have to spend another couple weeks creating that piece again. Well, if you have it in a digital file, you can 3D print it no matter how complex it is. In fact, you can add complexity that you cannot get on a potter's wheel, and you still get the privilege of glazing and putting it in the kiln. So another use of 3D printing, because it's all about printing by the layers and just changing the material composition slightly. Entertainment has been a user of 3D printing for many, many years. We have scans of almost every actor on the face of the earth, and the scans get used for a couple of things. The collectibles that come out after the movies, whether it's in your Happy Meal or whether it's a high-end collectible that fanboys pay hundreds and hundreds of dollars for. And we're also able to help the movies use the scans in some of the action. So that's another really important use, plus props, movie sets, et cetera. So a long-standing use of the technology, but we do think that this industry is going to take even further advantage of it in the future. Food printing. Okay, so Cindy told you that we are making an inroad into the consumer. And I'm going to show you other uses and other printers. But I think the real way to our hearts is probably through food. And people spend days making beautiful creations on Cake Boss and everything else that we watch. Well, we can do these in a matter of hours, and they're tasty. You can have chocolate flavors, you can have fruit flavors. It's almost unlimited, including having a special absinthe serving, which we created for mixologists. So almost anything is possible with food 3D printing. But there's another reason why we decided to get into this, and that is we think that there is an ongoing need for personalized nutrition. And by starting off with foodstuffs that we love, that we use to celebrate life, etc., we can ultimately move into a time of customized food for populations that don't eat well for a variety of reasons, for countries that may not have all the right foodstuffs for some reasons, but it really is the key to a future. And if you think about wearables today and the kind of information that they're collecting on us, the wearable could ultimately send a message to the 3D printer that you're low on a certain vitamin, and we could then customize the bar from that data. So again, think about food and how that could change in the next few years with 3D printing. Entrepreneurs. These are one of our favorite groups because they have great ideas. But what they usually run into are lots of issues getting their product into the market. Using a service or a low-cost 3D printer, we're starting to eliminate those barriers. We have a company that started, it's called 360 Heroes. They created a bracket to put multiple GoPro cameras together so they could do a 360-degree view. And they've created some amazing videos. They've launched their company. And now, of course, after they prototyped it on a $2,000 printer, they use the parts service to actually manufacture for them. So with no entry cost, no capital investment, they were able to start their company, and they're doing extremely well. And I want to share another story with you.
And let me tell you how I went from an idea to a product in a day. About a year and a half ago, I had an idea for a bicycle accessory. It's a simple silk flower and a clip. At breakfast time, I had an idea for a bicycle accessory. By about 9 a.m., I was designing on CAD the clip. By about 10 a.m., we were printing the clip on the 3D Systems 3D printer. I went straight down from LA, the flower district. I bought a beautiful array of different colored flowers and lotus flowers and daisies and lots of different varieties. By about 2 p.m., I was back home. We had the clip and the flower, and we put them together, took the photographs, put my pictures uploaded on Etsy on the seller's website. By about 6 p.m., I had my first order. So I went from an idea to market in a single day. So the next day, when all the orders came in, I had to figure out a way how I was going to fulfill these orders. So I uploaded the CAD file to kiwifile.com, placed a larger order, and within 48 hours, I had a whole pile of clips, and I was able to fulfill all my orders, and now I've got lots of happy customers.
So that's a great story. And by the way, those clips took all of about 30 seconds each to print because we nest them in a build envelope and print thousands and thousands at a time. So that's one of the powers of 3D printing. Now, we're also working on the broader consumer market and trying to get these technologies into the hands of our families, our kids, our entrepreneurs, our people that want to work in their man caves. I'm sure eventually we'll be in the she sheds. Have you all heard about the she sheds? That is going to replace the man cave, believe me. I'm going home and building my she shed. I read about that on my way. So here you see they're scanning. They're going around the city scanning. You can capture moments where people are doing things together. We could have scanned you somewhere out on one of your favorite locations here in Bermuda. And then it can be 3D printed and given as a gift or a collectible. Up in that top corner, you can see that you can create fun things like quadricopters. And once they're 3D printed, they can fly just like any other one that you might buy for $1,000. But here you can actually print it. And we have a kit for printing these types of quadcopters. So this democratization effort is well underway. We've been at it for a couple years now. We're seeing thousands and thousands of these printers be purchased and go into homes, go into libraries. And I really think this next slide shows the power of the technology, because when we're in a library, when we're in a classroom, we don't see people hanging back wondering what it is. These kids go up and they start to interact. They'll watch what's printing. We teach them how to take a drawing into a CAD file and into something printable. And they take to it like ducks to water. And what's really powerful is many of our children, and I have a 7-year-old granddaughter, so I know this, they're spending a lot of time in the ether. They're online, they're playing games, they're looking at videos. This allows them to connect the digital world with the physical world and actually make something that they can share. And we've had one young boy get the printer that was shipped to his mother at home. She said, "Don't touch it." He opened it up, turned it on, and started printing things that he took to school the next day to sell. And he didn't get in trouble, but his mom was really pleased with how much he took to that printer. So, and this affects all of our children at all ages. This is an event we did at the Modern Museum of Art to engage their folks and help get them able to look at 3D printing and look at the technology and take advantage of it in their creations. And they've asked us to come back. So it's really an exciting technology that affects almost everyone. Now, yesterday we did this exercise that was really, really fun. And we all got to talk about how we would change travel. And one of you had an amazing idea that didn't get shared. And I just wanted to tell you, I was sitting there thinking, oh my God, I can't wait to get to this slide. This is my last slide. But it is a little video. And while this is playing, I encourage you to just dream, just think, just explore. Put away everything you know about your business today and think about a new competitor coming in from nowhere, unannounced, uninvited, but they're still coming. Think about your customers and being able to interact with them in a different way. Think about how much you can change everything.
Imagine if everything you needed was scaled down to a digital file and could be reproduced at any location. How would this change our relationship to physical objects? Imagine design is just data, and products can travel through the internet as code, produced on demand at any location. If products and designs are distributed in the same way as images and music travel through the internet today, how would our perception of those objects change? We bring production closer and closer to the consumer, regardless of the location and economic status. And will this localization of manufacturing eliminate the need for mass production? What if luggage was obsolete? How would this change our perception for travel? Send your luggage in an email, travel the world unencumbered, and arrive at your destination to find your luggage waiting for you. This future is already in our reach.
I don't know about you, but I'd love to travel like that. Thank you very much for your patience and time.